On this 2022 Silverado 2500 with the 6.6 diesel, P0101 is a mass airflow sensor performance code. In plain terms, the engine controller may be seeing airflow that does not line up with what it expects from the rest of the engine data. The truck may show an emissions warning, may have drivability complaints, or may simply store the code. The possible fault areas can include the MAF sensing element, its ignition, ground, or signal circuits, intake or charge air leaks and restrictions, EGR leakage, skewed pressure or temperature inputs, or PCV-related air leaks. Start with the basic system checks, follow a structured diagnostic approach, and if other codes are present, check what they mean first, instead of chasing P0101 in isolation. The B75C multifunction intake air sensor is more than just a MAF sensor. It also contains intake air humidity, barometric pressure, and intake air temperature sensor 1 functions. For the intake air temperature sensor 1 portion, low temperature produces a high resistance, 1,166 ohms at 40 degrees Celsius, 104 degrees Fahrenheit, and high temperature produces a low resistance, 97 ohms at 130 degrees Celsius, 266 Fahrenheit. The ignition feed comes through a fuse, the signal circuit is pulled internally toward 5V inside the control module, and the ground is chassis ground. For P0101, the diagnostic formula is performance-based. The ratio between measured and estimated mass airflow is either too low or too high for greater than 1 second. So do not treat this only as a dead signal code. The signal has to be alive, stable, and believable compared with the rest of the air system. Reproduce the operating conditions before judging the result. P0101 only evaluates after a specific set of monitor gates is satisfied. For this code, those gates call for ambient air temperature, warmer than -20 degrees Celsius, -4 degrees Fahrenheit. Battery voltage is greater than 11 volts. Barometric pressure, greater than 70 kPa, 10.15 psi. EGR position sensor, less than 1%. Engine coolant temperature, -40 to 117 degrees Celsius, 130 to 266 degrees Fahrenheit. Engine speed is 560 to 1000 RPM. Intake airflow valve position, greater than 85%. MAP sensor is 70 to 130 kPa, 10 to 19 psi. And vehicle speed, less than 3 km per hour, 2 mph. Once the gates are met, the DTC runs continuously for greater than 1 second. At idle, a typical MAF data range is 2,800 to 3,800 Hz. But the first verification step is simpler. With the engine idling, the MAF sensor parameter must be greater than 0 Hz. If it is 0 Hz, move into circuit testing. For context, the companion low and high circuit MAF faults are different from this P0101 performance check. Their monitor gate includes battery voltage greater than 11 volts and engine speed greater than 590 RPM, and the frequency runs continuously after the running conditions are met for greater than 1 second. Their setting formulas are MAF sensor less than 260 Hz for greater than 1 second, and MAF sensor greater than 14,000 Hz for greater than 1 second. That context matters because those faults point more directly at circuit low or circuit high behavior, while P0101 is asking whether the airflow value is believable. If the MAF signal is alive, increase engine speed slowly to 3K RPM and bring it back to idle. Then review the stored scan data frame by frame. The MAF sensor parameter should change smoothly and gradually as engine speed rises and falls. If it does not, go to circuit testing. Next, keep watching the MAF value while you wiggle the harness and connectors at the B75C multifunction intake air sensor and the K20 engine control module. The value should not spike or drop out. If it does, repair the wiring, terminals, or connector condition as needed. Command the EGR valve to 0% and watch induction system leak indication. The ideal value is 1.0 to 1, and the normal range is between 0.80 to 1.20 to 1. During this check, it should be stable. If it's out of range, shut the vehicle off and run the leak test. That test needs to pass before you call the MAF circuit bad. As a diagnostic aid, a value greater than 1.20 to 1, with EGR commanded closed, may point toward a leak after the turbocharger, an inaccurate MAP sensor, an inaccurate IAT sensor 3, or a skewed MAF sensor. A value less than 0.80 to 1 may point toward a leak before the turbocharger. Inaccurate map or IAT data, a skewed MAF sensor, EGR leakage when commanded closed, or PCV system leakage. After the scan checks, look for physical conditions that can make measured airflow disagree with estimated airflow. Check the B75C sensing element for contamination, visible damage, or water intrusion. Clean the sensing element if possible. If it cannot be cleaned, replacement of the sensor is supported. Also check for an EGR valve stuck open, a dirty or restricted air cleaner, charge air cooler problems, exhaust restrictions or missing components, collapsed or restricted intake ducting, loose clamps, intake manifold cracks, a missing or damaged O-ring at the B65 intake manifold pressure and air temperature sensor, and PCV oil separator damage or restriction. If one of those conditions is found, repair or replace as necessary. If the visual and air system checks pass, operate the vehicle under the required monitor gates, and also under the captured conditions if they show how the fault occurred. The goal here is to see whether P0101 sets again. If it does set again, continue into circuit testing. If it does not set and the previous checks are clean, the verification result is all okay. Before resistance testing, remember that it may take up to 2 minutes for all vehicle systems to power down before an accurate ground or low reference continuity test can be made. Turn the ignition and vehicle systems off. Disconnect the B75C multifunction intake air sensor connector and test ground circuit terminal 7 to ground. The specification is less than 5 ohms. If it is 5 ohms or greater, disconnect the appropriate ground connection and test from terminal 7 at the component harness to the ground terminal. That leg should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the circuit. If it is less than 2 ohms, repair the open or high resistance in the ground connection. With ignition on and the vehicle in service mode, verify a test lamp turns on between ignition circuit terminal 5 and ground. If the lamp does not turn on and the fuse is okay, turn the vehicle off, remove the test lamp, and check for less than 2 ohms between ignition circuit terminal 5 at the component harness and the output terminal at the fuse. If that is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, verify the fuse is okay and that voltage is present at the fuse. If the lamp does not turn on because the fuse is open, turn the vehicle off, replace the fuse, return to service mode, and verify the fuse does not open. Then operate each component on that circuit one at a time, using a scan tool control if needed. If the fuse opens with components connected, isolate by disconnecting components and repeating the check. If it opens with everything disconnected, repair the short to ground. If the fuse stops opening after one component is disconnected, replace the component disconnected last. If it opens only when a component is activated, replace the component that caused the fuse to open. Next, with ignition on and the vehicle in service mode, test signal circuit terminal 6 to ground. The expected voltage is 4.8 to 5.2 volts. If it is less than 4.8 volts, turn the vehicle off, disconnect the K20 engine control module, and check for infinite resistance between signal circuit terminal 6 at the component harness and ground. If resistance is less than infinite, repair the short to ground. If it is infinite, check for less than 2 ohms from signal circuit terminal 6 at the component harness to the other end at the control module harness. If that is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, replacement of the K20 engine control module is the supported result. If the signal circuit is greater than 5.2 volts, turn the vehicle off, disconnect K20, turn ignition back on in service mode, and test signal circuit terminal 6 to ground for less than 1 volt. If it is 1 volt or greater, repair the short to voltage. If it is less than 1 volt, replacement of the K20 engine control module is supported. With the engine idling, use the appropriate diagnostic test probe and be ready to repeat the action several times. Rapidly tap a 3A fused jumper wire between signal circuit terminal 6 and ground while monitoring the MAF sensor parameter. The parameter should be greater than 0 Hz. If it stays at 0 Hz during this test, replacement of the K20 engine control module is supported. If it responds greater than 0 Hz, Continue by testing or replacing the B75C multifunction intake air sensor. Only do this check after circuit testing has been completed. Turn the vehicle off, disconnect the B75C multifunction intake air sensor, and install the EL38522 variable signal generator. Set it to 5 volts, 5000 Hz, and 50% duty cycle. Connect the red lead to signal circuit terminal 6, the black lead to ground, and the battery cable clip to the battery. With the engine at idle, the scan tool MAF sensor parameter should read 4950 to 5050 Hz. If it is not in that range, turn the vehicle off, disconnect the proper K20 connector, and check the signal circuit between B75C and K20 for less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the circuit. If it is less than 2 ohms, replacement of the K20 engine control module is supported. If the scan value is between 4950 and 5050 Hz, replacement of the B75C multifunction intake air sensor is supported. After completing the repair, verify the repair and confirm the code stays gone. For P0101, there is one more check tied to emissions warning event data. With ignition on and the vehicle in service mode, look at the event data under the EGR system malfunction warning data list. The specified state is that all of those parameters display no. If any event data parameter displays yes, operate the vehicle under the monitor gates for the DTC identified by that yes parameter. If all display no, the result is all okay. Also remember that the DTC responsible for a driver information message or speed limitation must run and pass before that message or limitation clears, and that may require driving the vehicle. Clearing behavior for this DTC family follows Type A behavior. Separate from the P0101 path, if a companion low MAF circuit path is being handled, and the service emission system or service exhaust fluid system message is displayed, that path uses the reductant system tamper warning service bay test. That procedure is used to clear the applicable driver information message for that system. It is not the main P0101 performance diagnosis. The takeaway on P0101 is to prove the MAF signal is alive, smooth, and believable before replacing anything. Separate the air system checks from the electrical checks. Use the leak indication test to catch airflow faults, and use circuit and signal simulation tests to decide whether the fault belongs to the sensor, the wiring, or the control module. For more diagnostic training, visit stepdiagnostics.com.